Welcome back, learners. Now let us quickly look at an activity that you must know. Right. Now, the question says to us, name 2 experimental measures or techniques that can be used to measure the rate of the chemical reaction. You know, it's very important that as a learner in this chapter, you know very well, because this is normally an investigative type of question. The examiner can ask it in an investigative type of question because it's always an experiment type of question. So what is important for you is to know what are the experimental measuring techniques that you can use to measure the rate of reaction. One, you can use we can measure the rate of reaction by the product being formed by means of a gas collection. So sometimes the examiner can make an experiment where we have to use, you know, the Elmina flask, the tube, the rubber tube there, as well as the syringe to see how much gas has been formed in the reaction. So measuring the gas collection, okay, and measuring the products that will be formed during the reaction as a gas, okay, in different time intervals, that would be a way in which we could measure the rate of reaction. So we are looking at how long does it take for the gas to be formed, okay, at different time intervals. Then you will know if the rate of the reaction will be faster or the rate of the reaction will be slower. All right. So there I put a picture for you over here. What normally happens is that at the beginning of the reaction, in terms of the volume of the gas, we are expecting for the reaction to start faster. Okay, it will start faster. That's why the gas will do what? Will be formed more in the gas syringe, and you will see the I'm not sure what it's called, this thing inside the gas syringe. It will keep on moving away. That indicates that more gas has been formed. So it will start very fast at the beginning, and then as it goes over there, the reaction will start to slow down. As the reaction to slow down, it will basically come to a stop. So the moment you see a flat straight line over there, that indicates that the reaction has stopped. All right. Why has it stopped? That means that the reaction has come to a complete. Okay, you are done with the reaction. The gases are no longer being formed. The gas that has been formed is formed, and that is the conclusion of that. Then the other way in which the examiner might ask this experimental question, it can be measuring reactants are used if maybe the reactants are used up by means of the change in the mass of the reaction vessel. So sometimes the experiment could be based on measuring the mass at different time intervals. So as the mass does what? Increases, what are we expecting the graph to look like? Obviously, the mass will start being high over there. The mass of the Erlenmeyer flask together with the contents over there, they will start at the highest peak over there. Then they will start to do what? To decrease and decrease and decrease until the reaction comes to a stop. Or they can, even if it continues and continue until there is nothing left in the container. All right. So as you can see, the 2 different graphs, they indicate the different ways in which the examiner could possibly ask this experimental type of a question. All right. One, we said that it can be asked by when products are formed by means of gas collection. So they will be collecting a gas. When you see a syringe, okay, you know that we are measuring the gas. As the gas has been produced, as we produce more and more gas, that at different time intervals, we are checking how much is the reaction happening faster or is the reaction happening slower. And then over here, we will be measuring the mass. As the mass is decreasing, that means the reaction is taking place, and we will be measuring how fast and how slow the reaction is taking place. All right. That is one thing that you need to look at. Now we are going to look at a multiple choice question. I know you guys don't like graphs, but it's very important for us to deal with graphs because this question has a lot of graphs. The graphs below represent molecular distribution of a reaction at different temperatures. As you can see, we have the kinetic energy over here. We have the number of molecules. As you can see here, what is happening here? They're saying which one of the graphs above represent the reaction at the highest temperature. Remember, the reaction at the highest temperature will be the reaction that has more particles, you know, that will be needed to do what? To react. Remember, we are still looking at the Maxwell distribution curve, though we don't have the activation energy, but we are interested in how much particles, which one have more particles. So the ones that have more particles is this one over there, and then the correct answer would be D, and the correct graph would be S. All right, remember that in the temperature graph, the temperature, what we are interested in, how do you tell, even if the examiner did not tell you that this is a temperature graph, what you are going to be looking at is the graphs that are crossing and crossing. So as the graph is crossing over there, these are little particles, that is other particles, that is other part. The one with the highest particles is S, because it has the lowest peak. The one with the highest particles there is going to be S, because S will represent the one that has the most number of particles that have enough energy to do what? To react. And as you increase the temperature, the number of particles will have more energy to do what? To react. And that energy will be higher than or equals to the activation energy. All right. I hope you still remember that. Now, guys, let us quickly look at another activity as in a different way, the different way in which the examiner can ask the question. The question says to us, the group of learners uses different reactions of excess hydrochloric acid with zinc. Remember the word excess, you must know it from grade 11, where we were looking at the limiting and excess reagent. Remember, the word excess means that the one that has been left behind after the reaction has come to a complete stop. Okay, now the Zn or the zinc is to investigate the factors which influence the reaction rate, and the balanced equation for the reaction is given as follows. There is our balanced equation for the reaction. Then they say they use the same number of hydrochloric acid and 1,2 grams of zinc in each experiment of 5 in each of the 5 experiments. The reaction conditions and the temperature readings before and after the completion of the reaction in each experiment are summarized in the table below. There is my table, guys. I know most of you, when you see something like this, already your brain starts to block. But I'm going to advise you that no, just look at, study and interpret the graph, rather the table, thoroughly, so that you can understand it before you can go to the questions. Over here, I have the reaction conditions, I have concentration, and I know concentration is a factor that affects the rate of reaction. I have temperature. I know that temperature is a factor that also affects the rate of reaction. I have state of division, which is what? Which is the surface area. I know that the state of division or the surface area are also factors that affect the rate of reaction. So by just looking at the reaction condition, I know I have 3 factors that can affect the rate of reaction. And I have the different types of experiments over there. Experiment 1, 2, 3, 4, as well as 5. And then I have different concentrations. I have the temperature before and the temperature after. As you can see, the temperature before is less than the temperature after. And then over here, granules, you know, I've spoken about granules, I've spoken about chunks, I've spoken about the solid, you know. So solid, granules are solids, you know, powder, and then granules. You now know what is going on. And then over here, you have the time, okay, how much time it took for the reaction to take place. Now, with that information in mind, we can quickly go to the questions. Let's look at 4.1. 4.1 says, is the reaction between hydrochloric acid and zinc exothermic or endothermic? Give a reason for your answer by referring to the data in the table. From the data in the table, when I'm speaking about exothermic and endothermic reaction, what must come into my mind is temperature. Remember, decreasing temperature is endothermic, increasing temperature is exothermic. All right, now I check what was happening before the reaction started. Before the reaction started, I had the less temperature. After the reaction was taking place, what happened to the temperature? The temperature increased. So that indicates that the type of reaction here, according to the results, it's exothermic. This is definitely an exothermic reaction. Why? The temperature has increased. Okay, we see that because the temperature has done what? Has increased during the reactions. As you can see, the different reactions, everywhere the temperature has increased, and that's why we are saying the reaction is exothermic. So can you see it's important to go back to the table and read the information? Like now, let us move on to 4.2. 4.2 says, give a reason for the difference in reaction rate obtained for experiment 1 and experiment 2. So I know there is a lot of information that the examiner might have given you there, but the examiner will always guide you to say, let us focus on this experiment and this experiment. And quickly, by just saying that, I would like to use a different pen so that you can see when I am looking at which experiments. Now I'm going to be looking at experiment 1 and experiment 2, and that is going to be my focus for this question. They're saying give a reason for the difference in the reaction rate. If you look at experiment 1 and experiment 2, they have the same concentration. So concentration is not the factor that might have affected the rate of reaction. Temperature has increased for all of them, but what is different here is the state of what? Of division. Over here I have granules, over here I have what? I have powder. And what do I know about that? I know that powder has increased the surface area or increases the state of division. As the state of division increases or as the surface area increases, the rate of reaction will be faster. I will see that by the time. How much time did it take for the reaction to take place? As you can see, reaction 2 is faster than reaction 1. Reaction 2 is faster than experiment 1. As I said, experiment 2 is faster than experiment 1 during the reaction. Okay, that is what is the difference between experiment 1 and experiment 2. Okay, and what is the other the difference? The difference is that in experiment 1, the surface area is smaller, and in experiment 2, the surface area is larger. So you can say experiment 2 has a larger surface area than experiment 1, and experiment 2 has a faster reaction rate than experiment 1, and that is what makes the difference between the two experiments. I hope we are still together there, guys. Let's quickly move on to 4.3. It says the learners compare the results of experiment 1 and 3. Now we are done with experiment 1 and 2. As I said, the examiner will always guide you to say, look at this experiment and this experiment. So here we are looking at experiment 1 and experiment 3. So again, I quickly want to use a different color pen so that you can see that now I have looked at different types of experiment. I am looking at experiment 1 as well as experiment number 3. The question says, the learners compare the results of experiment 1 and 3 to draw a conclusion regarding the effect of concentration on the reaction rate. Explain why this is not a fair comparison. Let's go to reaction 1 and 2 to see why is this not a fair comparison. If we look at reaction 1, we have a concentration of 0.5. Reaction 3, we have a concentration of 0.8. As you can see, concentration is a factor that affects the rate of reaction. Okay, alone concentration is a factor, and because experiment 3 has a higher concentration than experiment 1, you would expect that experiment 3 would be the rate of reaction will be faster in experiment 3 than in experiment 1. But let's not stop there. What else makes it different? You can see here we have powder and what? And granules. So this is not a fair comparison because we are investigating two factors, more than one factor at the time. We know that concentration affects the rate of reaction. We also know that the state of division or the surface area also affects the rate of reaction. So it is not a fair comparison because both of them, we cannot look at their concentration alone because the state of division also has affected the rate of reaction. All right, there are two changes that have taken place. That is why this is not a fair comparison, or there are two independent variables that have changed the rate of the reaction. All right, so any of those answers that you think is okay is okay. All right, let's move on to 4.4 quickly. It says, how does the rate of the reaction in experiment 5? Now we are changing. We are done with experiment 1 and 3. Now the question 4.3 is looking at experiment 1, experiment 5 rather, with experiment number 1. So again, I quickly want to use a different color pen so that you can see that we are changing the experiment. Okay, it doesn't want to work, but it's fine. I'll use the same color because we are in a different page anyway. It says write down faster than, slower than, or equals to. All right, let us look at experiment 5 with experiment 1. All right, as we look at experiment 1 with experiment 5, they have the same concentration over there, they have the same state of division, but the other one, if you see here, the other one is faster. Experiment 5 is actually faster than experiment number 1. So the question, the answer here will be faster than. So I'll write here the question, the answer is faster than. Why am I answering faster than? Because the question is asking in terms of experiment 5. Will experiment 5 be faster than, slower than, or equals to experiment 1? I can see that experiment 5 will be faster because it takes less time for the reaction to take place, or for the reaction to complete, or for the reaction to happen. It took only 11 seconds, but in experiment 1, it took more time, which is 50 seconds, which will tell you that the rate of reaction in experiment 1 was slower. Then they are saying to you, write down the factor responsible for the difference in the rate of reaction and fully explain by referring to the collusion theory how this factor affects the reaction rate. Remember, I said to you, this question will always want you to refer to the collusion theory. Why increasing concentration, increasing pressure, increasing all of these things affects the rate of reaction. So now if you look here, concentration is the same, the state of division is the same, the temperature after is also the same, and the temperature before is the same. So if the concentration is the same, the temperature is the same, the state of division or the surface area is also the same, what could be the reason that makes experiment 5 be faster than experiment number 1? It's because we might have in experiment 5 added a catalyst. Adding a catalyst, that is the only thing that makes sense, that would have made the experiment number 5 to be faster than experiment number 1, because all the other factors are the same. All right, all the other factors are the same. So I'm quickly going to go to how I would have answered it. I would have said faster than, and then I'll say as all the other conditions are the same, there must have had been an addition of a catalyst to a reaction, like I've explained. Why? Because a catalyst provides an alternative pathway for the reaction with a lower activation energy, or for a chemical reaction to occur, and there will be more reactant particles with average kinetic energy equals to or greater than the activation energy, and more effective collisions per unit time, and this will affect the rate of reaction. Thus, the rate of reaction will be faster. Guys, I hope you are seeing how we are actually using the collusion theory to answer the question. Now let's quickly go back to our question. We have answered 4.4. Now we are going to quickly move on to 4.5. 4.5 says to us, calculate the rate at which the hydrochloric acid reacts in experiment 4 in moles per second. Remember, we said that rate can be calculated using either moles per second, concentration per unit time, or also the mass per second or per unit time, depending on what the examiner is saying. So here the examiner has guided you to say they want their rate to be in mole per second. That means they are looking for the number of moles. All right, do you want to calculate the rate as the change in number of moles of reactants or products per unit time? So here we are calculating for hydrochloric acid for experiment 4. So again, we are going to be focusing on experiment number 4. What do I know about experiment number 4? I have the concentration of 0.5. Okay, I have the time over there, I have the granules, I have the temperatures, but I have the concentration at the beginning of the reaction. That is what is going to assist us. And also remember our question from the previous activity, from the statement itself, we were given something about zinc, and we were told that our Zn, hydrochloric acid, is what? is in excess. Remember that hydrochloric acid was not used up completely in the reaction, but we want to calculate the rate, okay, using that. So let's quickly go to how I have done it already. So without wasting any more time, I'm going to explain how I've done it. So the first thing that you are going to do is convert the mass of what? Of hydrochloric acid, okay, the number of moles of hydrochloric acid. We're gonna convert that 12 grams into we're gonna divide the 12 grams with 65, which is the mass number for Zn, which is zinc. We will get 0.018 moles. So we have converted the number of moles of, the mass of Zn, which is zinc, to number of moles. Therefore, we then that's the total number of moles of hydrochloric acid that will be reacted will be 2 times of that of zinc. Why? Because we'll be looking at the mole ratio between Zn and hydrochloric acid. All right, between Zn and hydrochloric acid, the ratio is 1:2, and that's why we are multiplying by 2, and then we have multiplied the number of moles of the Zn, and we got that 0.037 moles. So this 0.037 moles are the number of moles of hydrochloric acid that have reacted. All right, now that we know the number of moles of hydrochloric acid that have reacted, we can quickly go to calculating the rate, okay? Remember, this is the rate of the reactant, so I forgot to put a minus there. Why is it the rate of the reactant? Because remember, it was Zn. Our equation is Zn plus hydrochloric acid. So Zn and hydrochloric acid are our reactants. So we are calculating the rate for the reactant, so we must put a minus there, because remember, the reactants are used up in order for products to be formed. Then as you put a minus over there, you will say the final number of moles of hydrochloric acid and of hydrochloric acid, yes, which is HCl, it's 0 minus the 0.037. That will do what? That will react, and we divide that with what? With 8, which is the time that we are given. And then when we punch into the calculator, we get that negative 4.63 times 10 to the power negative 3 moles per second. And remember, I said your rate must always be positive. That's why here I've indicated, therefore, my rate will be 4.63 times 10 to the power negative 3 moles per second. All right, so it's very important that you understand the difference between excess and limiting. Remember, we were given them the mass, okay, in the previous question. You can quickly go back at your own time and look at it. Right, guys, thank you so much. Let us quickly take a screenshot of today's homework. Please look at the homework here. I hope it is going to assist you, and what we have done together as an activity will assist you to do this homework on your own. So quickly take a screenshot so that you can be able to practice that at home. Right, guys, thank you so much. Let us quickly look at our preview of our lesson. Remember, we spoken about the collision theory. We said that in order for particles to form the products, they must do what? They must collide with each other. They must collide effectively. They must collide with the minimum energy that is equals to or higher than the activation energy, and there must be effective collisions per unit time. Remember, we said there are factors that are affecting the rate of reaction. We said increasing temperature, okay, temperature will affect the rate of reaction. Increasing concentration will affect the rate of reaction. Increasing the surface area will also affect the rate of reaction. We said that adding a catalyst will also affect the rate of reaction. And then we said that the nature of the reactant will also affect the rate of reaction. We increase the temperature, the rate of reaction will be faster. Increasing concentration, the rate of reaction is faster. Increasing surface area, the rate of reaction is faster. Adding a catalyst will also make the rate of the reaction to be faster. The nature of the reactant, if it's ionic or a polar, in a polar solution, then the rate of reaction is most likely to be higher. We also looked at the Maxwell-Boltzmann distribution curve. We said that the shaded area, remember, it looks something like that. Then we said the shaded area over there represents the number of particles that have enough energy to react, and that EA represents the activation energy. Anything before the EA, those are the number of particles that don't have enough energy to react, all right? Because in order to start the reaction, there must be enough energy, and that energy is the activation energy, which is the minimum energy that is required for the reaction to take place. Guys, we looked at graph interpretation. We looked at the concentration versus the concentration graph. We said that the concentration graph has two graphs, okay? The one with the highest peak is the one that will represent increasing concentration, because it will indicate more particles that have enough energy to react. Then we said the temperature graph, it crosses. Then the one with the lowest peak will have more particles that will be needed to react, okay? And then we looked at stoichiometry calculation. What you need to do over here, when you are given the mass, all you need to do is convert to number of moles, okay? If you are given the concentration, all you need to do is convert to number of moles. If you are given the volume, again, all you need to do is convert to number of moles, and know what the examiner means by limiting reagent and excess reagent. Remember, calculating the rate, we said we indicate the negative equals to negative change in concentration of the reactant over the change in concentration of the time. We put change in time rather, and then the negative we only include it when we are calculating the rate of the reactant, and we don't put a negative when we are calculating the rate of the product, because the products have increased and because new products are being formed in the reaction. Guys, I hope you understood the summary and the preview of the lesson. I hope you enjoyed today's lesson. And again, thank you so much for joining in today's lesson. My name is still Dimpo Rampora, and thank you so much for watching.